When you account for the loss of energy due to friction, gamma, you get a modified equation with an extra term in the denominator. Now there's no way to get an infinite amplitude anymore. Even if you pick your forcing frequency to match your natural frequency exactly to produce resonance, there will be a small term in the denominator that makes the amplitude finite. We can visualize the system response by looking at a plot of the square of the amplitude versus the forcing function. Amplitude squared is proportional to the energy within the oscillator. We can clearly see that frequencies close to the natural frequency result in a much larger energy, even though the actual input energy is not that large. Notice also that the width of the curve, which we take as the width at 1/2 of the height, is approximately gamma, the friction component. If the system has a small gamma, or very little friction, the curve gets taller and the width gets narrower. This means the system can build up to store much more energy, although the range of frequencies for resonance to occur becomes much narrower. Another measure for this width is something called the Q factor, which is equal to omega naught divided by gamma.